Okay, good morning. Doing this video to go over the 11G notes here. These are just some special permutations that we're going to do. This is the last set of notes that we're going to do. So, circular arrangements. So, circular arrangements is when we have objects arranged in a circle. Um, it's a little different than a regular permutation. So, for instance, a regular permutation, we have something like A, B, C, D. Okay. Whereas if we have A, B, C, D in a circle, it may look something like this. A, B, C, D going clockwise. Okay. Now, in a permutation, let's say we have another permutation with this, which would be D A B C. That is a different permutation than A B C D. Okay, that is a different permutation than A B C D. However, if we're talking about circles, okay, and in terms of objects being arranged in a circle clockwise, okay, well, if we have D A B C, all right. If you notice, these are like chairs around a round table. D is in between C and A still. Okay. C is between D and B. Okay. B is between A and C. Okay. And A is between D and B. Okay. So if we look at clockwise, like a clockwise thing, A to B, B to C, C to D, D to A. Okay. A to B, B to C, C to D, D to A. This circular arrangement is the same as this circular arrangement. Okay. In permutations, in a straight line, it's different. Okay. In a circular arrangement, it's not. Okay. In a circular arrangement, it's not. Okay. So what we're gonna do is let's go down here, and I want to do the sample space just for ABCD. Okay. So we know our sample space for ABCD is going to be 4 factorial, which is 24. Okay. So 424 factorial, which is equal to 24. So here's our sample space. We have ABCD. Okay. We have ABDC. We have ACBD, ACDB, ADBC, ADCB, like that. Okay. So those are our 6 permutations that start with A. Okay. It's our 6 permutations that start with A. Now, I just want you to notice sort of the order: A, B, C, D, A, B, D, C, A, C, B, D, A, C, D, B. That's a B right there. And all these. Okay. What's going to happen is as we do the rest of our sample space, all these orders are going to sort of repeat themselves. Okay. So let's start with our B's. So let's say we have B, A, C, D. B, A, C, D. Well, if we did B, A, C, D, I'm going to put that here. Okay. Because what happens with B, A, C, D, this B, A, C, D follows the same order as this here. B, and then A, C, D. It follows the same sequence. So if these numbers were arranged in a circle, in a clockwise circle, BACD would be the same as ACDB. Okay. If we have BADC, okay. If we have BADC, okay. B and then ADC, B then ADC, that sequence would be the same as that sequence, again, if they were arranged in a circle and we were going clockwise. Okay. Um, Next, let's say we have BCAD. Well, BCAD is the same sequence as ADBC because B, then C, then A, then D. Okay, if this is a clockwise circle, it would look the same. BC DA would fall under here because it's the same sequence: B, C, D, then back to A. B, C, D, back to A. Okay, so in a circle, it looks the same. Okay. Um, Last, we have BDAC. Okay, and then we have BDCA. Okay, so again, as you notice, um, we have 6 things right here. We have 6 different permutations with our A's, but these permutations are going to repeat themselves all the way down. If we're thinking about sort of a circular thing right here, because again, the whole concept is ABCD is the same as DABC, because if we're looking at sort of a clockwise setup right there, the same letters are next to the other letters. Okay, so in this scenario over here, we'd have CDAB. Okay, and we'd have DA, BC, like that. All those would sort of be the same. Here we have CA, BD, okay, and here we have DCAB. Here we have CBDA, and here we have DACB. Again, all the same order, sequencing, okay, in terms of a round table. Here we have CDBA, DBAC. Okay. So underneath here we have CADB, and here we have DBCA. Okay, those all fit there. And here we have CBAD, and here we have DCBA. Okay, so there's 24 total permutations. Okay, in terms of a linear sequence, but again, if we were to arrange these in sort of circular arrangements right there, all these are the same, 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 and all these are the same. Okay, so we end up with 6. Okay, we had 24, now we end up at 6. So what happens is basically we have 6, which is 3 factorial, all right, because we have, you know, all these repeats here. Okay, so what ends up happening is the formula for it is just going to be n minus 1 factorial. If we have n number of objects arranged in a circle, okay, circular arrangement, the formula is just going to be n minus 1 factorial. All right, next one. Let's suppose we have A, B, C, D, E. Find a number of permutations. Find a number of permutations. Of course, we would just do that by 5 factorial. 5 letters, A, B, C, D, E, which is 120 sample space, okay? However, let's say we were to do it separately, but we wanted to keep A and B together, okay, in order A, B. Okay, so we have, an A, B. So what we're going to do is we're going to treat, okay, we're going to treat A, B as one character, okay, which is going to get us down, okay, to basically what we're going to have is we're going to have 4 slots instead of 5, okay, which is going to end up making us have a 4 factorial, okay, because let's think about this for a minute here. So A, B have to be together, okay, so we could have A, B, C, D, E, A, B, C, E, D, A, C, B, D, E. Oh, check that. We can't even do that. Whoops. Sorry, all these freshmen are making a bunch of noise. Sorry about that. We're back. So we have A, B, D, C, E. We have A, B, D, E, C. All right, and we have A, B, E, C, D. And then we have A, B, E, D, C. Okay. However, we're going to treat it like 4 slots because A, B has to go together. A, B has to go together. A, B, A, B, A, B together, right? And the other 3 slots are all going to be different. Okay. So the other 3 slots can be whatever we want. Okay. So A, B, we're going to treat as one character. Okay. The other 3 slots, we could have whatever we want. Okay. So if A, B wants to be the second character, for instance, we would have, we would have 6 different permutations of something like that. Okay. We'd have 6 different permutations with A, B being a second letter down here, all the way down the line. Okay. All right. So again, we'd have 6 of those, and then we would have 6 with AB being the third thing, and we'd have 6 things with AB being the fourth thing. So, we end up with 4 slots again. So 4 factorial is 24. Now that's if AB stays in order of AB. Okay. So if AB, goes, if A and B stay together and then they're in the order AB always, it always goes A then B, then there's going to be 24, 4 factorial. Okay. Now, if we were to keep A and B together in order AB or BA, right? Well, now we have 24, but then AB and BA are different, so we could have 2 factorial after that. Okay. So it would end up being 48 because we would have 2 factorial for our AB slots. Okay. 2 factorial for AB. Okay. And we would have 4 factorial because we're still treating it as 4 total slots, which would be sort of like 40, which would be 48. Okay. So basically, you take all this sample space that we would sort of do here, okay, and then do it again with BA instead of AB. Okay. So we would do 2 factorial if we had to just keep, if it was AB or BA. Or if the question was asking something like, just keep A and B together. Okay. So it'd be 2 factorial, okay, for the A and B because they're together, times 4 factorial because there's 4 total slots. Okay. Last thing I want to talk about is if we have a permutation of 5 boys and 6 girls and boys and girls alternate. Okay. Boys and girls alternate. All right. So if we were to have something like this, what would happen is, we're going to have 5 boys and 6, permutation of 5 boys and 6 girls if they alternate. Okay. So what we're going to have is we're basically going to have 11 slots total. All right. So 11 slots. Boys and girls have to alternate. Basically, what would have to happen is we'd have to have girl, 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 boy, 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 boy. Okay. So what would happen is we have 6 girl slots, and so the girls can be arranged 6 different ways. So 6 factorial for the girl slots, and we would times it by 5 factorial for the boys slots because the boys and girls have to alternate. Okay. So the rest of these practice problems y'all can kind of do on your own. We'll talk about them in a little bit, but that should sort of take care of most of this stuff. So y'all can sort of try out the 3rd and 4th pages on your own, and then finish these practice problems up in here. Thank you, and you guys all have a terrific, wonderful, super day.